Another DraftPhysics.com video presentation. I must say, I am profoundly disappointed. So that would probably please some people. They'll be happy that I'm unhappy. But yes, I'm disappointed. But what I'm disappointed in is intelligence. I thought there were smart people and dumb people on Earth, and I sort of had this idea that the smart people will put on their Superman suit and save the day. That problems can be solved with intelligence. That there's good reason for people to invest in being intelligent. That has its own rewards. That you live a good life. It'll make you more honorable and decent, and do lots of great things for you. But it's really not true. As I'm learning, people with well-educated don't seem very smart. They don't seem to have any integrity. They don't seem to have gleaned any of what they should have gleaned in the process of acquiring knowledge of existing on Earth. And that's really tragic. Because without them to save the day, there won't be anybody to save the day, and so the day won't be saved. The truth won't win. Efficiency won't rule the day. The progress won't be in the right direction. We're just going to get dumber. Idiocracy will win. Blah 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 blah. And that's just a big fat story of waste. Then waste will win because people can't be educated. They can't be. They can't go off the narrative. Whatever mommy told them, Professor Mommy Lewin, whatever they were instructed, by their revered instructors, they can't fix anything that's broken. It's the simple truth. No matter what's broken, they just sit there and pretend it's not broken. They won't even pull out some duct tape and do a little bit of work. They just run away. I don't want to know. I don't want to see there's a problem it creates. I don't want to know about any problems created. I just want to know how much money did I make? What did I get out of the deal? And that appears to be all that's motivating people. Just, sad. All right, so I have explained the horrible history of kinetic energy. I have pointed out there's just zero evidence. So even the dumb people can figure out, oh, this does smell kind of fishy. You don't have any evidence. That's not good for scientific theory. No evidence? Oh, yeah, that's... and it sounds kind of wacky and contradictory. Somehow you can pour all the paint into the bucket and spill half of it. Yes, that doesn't sound quite right. The dumb people can figure that out. So they say, okay, Gary might have a point. But the smart people, they can't admit it. Smart people have made a mistake. Someone in our group made a boo-boo. No, we don't make any of those. It's just so childish. So anyway, so I have explained the bad history, the fact that there's zero evidence, and that the contradictions are kind of obvious. And so I'll explain a little deeper just how bad this is. And it's just as bad as, like I said, 200 years ago or so, they kind of figured out that all the force things, that is all this stuff that's elemental, moving the speed of light, it's all the forces, gravity, magnetism, and light. It should be the speed of force, should be sort of the definition, because all the stuff that's moving stuff in the elemental form is all moving the same speed. And so, bent space, that really can't work. It should have been a huge non-starter for Einstein's introduction, because Maxwell had already figured this out. It should already been kind of stated that, no, you can't create this bent space theory, this whole separate mechanism for moving stuff, because we already know everything's moved by this force stuff going the speed of light. So until you make your gravity theory into something that's inclusive, that connects to the other theories, until you make it out of virtual photons, there's no point in talking about it, because it really has to be virtual photon. It really has to be the same thing that's making the magnets move. And it's just silly, to invent some whole new physical mechanism that doesn't have any physicality. So anyway, so that one should have been, there should have been some resistance to jumping on that bandwagon. This energy theory, it has the same problem in the sense that I guess we don't even need the other screen. Nothing to report. I mean, there's just no progress in this attempt to provoke a conversation. I can't get any rational feedback. Just zero. They are such cowards. It's pathetic. All right, so we know things like, you have a magnifying lens, and there's all this energy coming in, and you can stick your hand in it, right? Stick your hand right in the energy, and it doesn't do anything, right? But you put this lens in front, and it's not a magic lens. It's not creating kinetic energy, free energy. All it's doing is taking what's here, okay, and it's putting it into one single little place, creating a focus. And so all the energy that's spread over here ends up in one tiny little location. And so it's, in a sense, a velocity condenser. And so, velocity is doing the same thing. When you have velocity, what you're really doing is taking a tiny bit of matter and putting all the momentum, all the speed on top of it. All the go is in this tiny little area. So in a sense, it's the same thing as a magnifier. Big mass means spread over a big area. Small mass means spread over, a tiny area. And so you can end up, it's just essentially just another metaphor for, okay, so you can see the connections. You see, this should have been part of the logical diagram they drew in terms of understanding. And they almost had it. I mean, they all sort of, even the people creating the silly formulas, all kind of knew that heat was related to energy. And it's just kind of obvious what's, you can sort of understand. Now, why does this do so much? Why is this energy so much different than this energy? Well, the key fact is now that we have some nuclear science, you can understand that atoms have these electrons in them. And the real thing you're saying is, okay, I'm going to hit, electrons with force. So when I bring another electron close to this electron, what I'm really doing is creating more pressure. The electrons don't like each other, and so there's this virtual photon, which is really, just energy, just the force, the little vectors of momentum flying through the universe. And so you're increasing the amount of times this little bit gets hit. And the fact is if you bring more than one electron, if you start pushing it with more and more pressure, you hit it with enough pressure to knock it out of the atom. And then it bangs into another electron or another atom, and so on and so on. And so what you're doing when you're focusing the light is you're turning a simple push. That is, I pushed into this electron, it distorted the atom a little bit, no big deal. Maybe the atom moves a little bit this way. The heat doesn't do it, the pressure doesn't do anything substantial because everything can move at its own rate. It doesn't have to immediately do anything. It doesn't catastrophically break anything. It doesn't break the glass. You could just see. So you can always come up with a metaphor. You could just say, it's like a glass, And you can hit a glass and it doesn't break. But you hit it hard enough and it fractures. Well, the same thing happens to atoms. You can break the chemical bonds between the molecules. So if you have a molecule that has more than one atom in it, you can end up knocking pieces off. And making these atoms flying around hitting each other. And the fact is they can end up going faster and faster. And the faster they go, the more damage they do to each other, the more they break down each other's stuff. And that's what's really happening. So all you're doing is making the atoms move too fast. They can't dissipate the energy quickly enough. So the interactions aren't happening fast enough for the pushing energy just to be pushes. So instead it's going in so fast the glass can't bend to it. So it breaks. The piece of wood can't bend. The pressure's a little too strong. Can't spread it out. Can't get rid of it quickly enough, and so it breaks. And that's all that's happening on the molecular level. It's the same kind of idea. You're just breaking stuff, and so now you're creating energy that's flying off in all kinds of directions. So, burning and burning energy. Okay. So you're taking heat that would just be a gentle pressure. If you could put it over enough atoms, it would just be a little push, and you're turning it into a poke, a jab, a stab, okay? And the same thing happens with velocity. Velocity, just like the burning little focus of this energy, when you put all of the energy, you combine a whole bunch of little bits pushing in a direction, okay, a little bunch of little vector arrows on top of one area, then you're forcing one atom, or just a small number of atoms, to deal with all of that pressure. And they can't. If you spread it over the surface of the glass, it doesn't break. You hit one little spot, it breaks. Same thing happens there. And that's what you understand is, okay, that's the difference. There isn't more energy here. Same amount of energy here as here, equal sign, right? Same energy here as over here, okay? Same energy. You can understand it. Same energy. Okay, there's not more energy. There's not some v squared energy. There's no extra energy. It's just that you have focused the energy. You are forcing the energy to all be stacked in one place to affect a small number of atoms, and therefore it has a different effect than it would have if you spread over a bunch of atoms. And that's all there is to it. It's that simple. I really, all of this work. See, all this physics would be okay, if physicists were smart, if scientists were smart, they would say, like every 6 months we should have a convention where we have to re-establish our premises, and make them logical, and test them. Because, this is what gets them into trouble. Is that once they establish something to be true, 1/2 mv squared, well, then they start, then everything starts to adapt to it. They start writing new formulas for work and make those compatible. Let's put an mv squared in there, and then they make another thing over here for, I don't know, comfort. I'll put an mv squared in there somewhere, and so everything starts to become interconnected and interdependent. And if the premise is wrong, then they get a whole bunch of stuff built on top of that wrong premise. It's just building on a foundation thing. You don't want broken counterstones. You don't want imaginary counterstones. Counterstones? Oh, that's not the right word. Cornerstones. Counterstones. Counter space. Anyway, it's made out of counterstones. So the other subject I thought was worth filling with is friction. Okay, so I've already sort of explained, all right, that Newton's third law of action equals opposite reaction is really a little too simplistic. That what you're really doing, is you're actually, you're pouring something into something else. So when you do that, when you pour your stuff, you're over here and you're going to interact with something, and you're going to take your stuff and you're going to put it in here. Well, when you do that, you automatically get the opposite reaction in the sense that you don't have the stuff anymore because you poured it into the other guy. So that's the opposite reaction in most cases. The opposite reaction is that if I pour my stuff into him, yes, he's different and he's going to do what I'm doing. But I'm going to lose what I was doing that, and now I'm not going to do that anymore because I poured it into him. So I don't have it anymore. There's no opposite force stopping me. I stop because I took my foot off the gas, kind of thing. It's not, well, we'll get to friction. That's the subject I really want to get to. So it's not really, in every case, in most cases, the opposite reaction is not an opposite reaction. It's like me, if I pulled my head off and gave it to somebody and now they have my head, you don't need an opposite reaction to take my head off. I already took it off. It's part of the action was me removing my head and handing it to you. So I don't need an opposite reaction to take my head off because I already did it for you. When I gave you my head, I already disconnected it. So it might look like there was some opposite effect on me. The opposite effect is I don't have a head. Well, obviously I don't have one because I gave it to you. All right, so it's a subtle thing, but it's important. These are important distinctions. All right, so they'll often talk about friction and they'll draw it like it's a vector, like it's an actual force. Friction is a force. And it's really not a force. It's just another place where you're making a transfer. You're connected to something, And that connection is going to mean that you'll transfer your energy to it. It's just connecting you to other people's buckets for you to pour something into. So, you know, a surface is basically just a bunch of these vessels that can accept, you pouring your paint into them. And so you're riding along with your bucket of paint. And, it doesn't matter who really has the paint, by the way, right? I mean, I could put the paint in these buckets and it could go into my bucket, or I can put it in this bucket and pour it into their bucket. Same difference. So the thing is that if there's gravity, what it's basically doing is it's making you connect. So the gravity pushes you down into a surface. The pressure it's applying is basically, causing your bucket to spill as it gets pushed across the pressure. And so you're just basically just transferring your stuff into their stuff. Now, obviously, it's more complicated in the sense that, there's friction works in a sense that you can, when you're stuck on something, you actually do make some kind of, molecular attachment. And you have to break that. So if I apply in a force to try to move something, I have to first break it free, and then I get to see what the real friction is. The real friction is, there's a certain amount of gravity pushing down. There's a certain amount of this surface I'm connected to. I'm spilling some of my paint into the ground. So, but the initial lock is stronger than the friction once you're moving. So first you have to get something to break free. Okay, and that's a molecular thing. And once it's free, then you can start just spilling less paint. So you have to spill quite a bit of paint. I mean, you have to push quite hard sometimes to get something free. And once it's free, then you're bouncing on the friction road. And all you're really doing is you're giving your momentum to the stuff you're hitting. So because gravity is pushing you down, it's forcing you to hit the stuff. By hitting it, you're like bowling pins. It's like the ground is made out of little bowling pins, and you can't help but push it. So if you're in water, it's the water molecules. You got to hit the water molecules. Bang, 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 bang. I got to move them, move this. When I spill, they all take my paint. My paint has to move them. My energy. And in the air, is much fewer of them. A million times less dense or something. But you still got to hit them. You still are moving crap, and so you're really just swimming. And the more humid the air, the more air resistance, because you got these extra water molecules floating around. In the oxygen, the nitrogen, you got all this water crap, and it also push around. So you can think of it. It's just like the atmosphere is like water, and you have to just think of it's like really thin. It's really thin water. So obviously it's easier to wave your arm in it without hitting too much of it and having to lose your energy to moving the atoms. That's all you're doing. So energy is just, when a force is flying free, it can't be doing any work. So when you make the force hit something, like it hits an electron, now it moves the electron. Now it's working. Now the force is in working mode. Okay, and now it is energy, in the sense that now that, movement will cause movement in another object, because force will bounce between the electrons and it'll push this electron and convey the movement. And so the work is only while the force is occupied moving an electron or a proton. So now we get to the gravity explanation, where it all fits in. And so, you have to understand that. So the stuff moving the speed of light is not working energy. That energy is not working. Now, it will work. As soon as it hits matter, it's going to start working. But technically, it's not working while it's going the speed of light. And it's when it's pushing a piece of matter, that's when it's doing work. That is what you're going to end up frankly, you're going to need to cause effects that you'll call energy in the universe. So the force has the energy, but it's just, obviously it's not doing anything when it's moving the speed of light. You can sort of understand it's not working. So it's not active energy, and it becomes kinetic or active when it starts moving electrons when it's pushing one. Okay, and so that's what pushes us, that's what moves everything, is the electrons have to be moved. And then the atom moves, and then the whole body moves, and blah, blah, and so on and so on. So it's only the portion of the force that's actually pushing an electron or a proton at any one moment that is really the energy of the universe. So the energy in the universe can kind of move between pushing matter or being free. And that would be essentially gravity, would be the disproportion between those two things. So gravity can change subtly, how much any mass would create in terms of gravitational effect just means how much of the energy of the universe is actually pushing matter. Anyway, but the simpler, more poignant argument to make is that's what's happening inside of objects, when that's what heat is, and all of that kind of stuff is just moving, taking a force and causing it to move a piece of matter. And so the force would be here in space, but if it hits a piece of matter, it's got to push it, and it moves it much slower. So it won't get to the location at the same time, which means essentially it's going slower. So the force is only going as fast as the matter it's pushing. So it has a huge degrade in its energy as a force, because it's not going to go as where it would have gone if it maintained its speed, and instead it's pushing this stupid piece of matter. But the fact is the pushing of the matter means the matter is probably going to interact with other pieces of matter and push those, and that's going to, so it's going to stay as a pushing force, but it's clearly going slower, and that's really the nature of gravity. So gravity just means that you have a mass where you have a certain amount of energy coming in that's all going the speed of light. And the fact is that the energy, gets involved in pushing electrons around, and so it's going a lot slower when it's in here, because it's moving electrons, and that's the heat. That's like the Earth is molten in the center, very hot. Well, why? Well, because it's actively, this force on the outside that came in is now hitting electrons and spending time moving the electrons around, so it's not getting out when it should have. So it's being delayed in here, and the delay in here means there's more goes in than comes out. Constantly everything has to keep moving. So everything is replaced. Like say the piece that gets, this piece of energy that went in, say, 1,000,000 years ago, and it's been pushing little pieces of matter. Someday, some opposing force will hit, and that piece of energy will be free, and it'll go back out into the universe again. It could be 10 seconds. It could be 10 milliseconds. It could be 10,000 years. Who knows? But it really doesn't matter. The point is that you just end up with this idea that you have a constant deficit created, where there's constantly more energy going in, at the speed of light, than energy coming out, because you've delayed it all, moving little pieces of matter. And so there's always a deficit, a constant deficit created, because the energy has been delayed. It hasn't gotten from going inside to the coming outside. There's always a delay, and that perpetual delay means there's a perpetual net more energy on the outside than there is energy on the inside. Going out. So you fall until you hit where the energy becomes equal again, where the pressure of all the moving matter pushes you as hard as the force, the speed of light force. So the slow moving matter hits you with as much energy as the free force that's coming from the outside. So that's one way of saying it. All right. So that's probably enough. I just wanted to touch on friction's not really, everything's a force in the sense that everything has a it's moving through space. So everything that has matter is, you could theoretically say, has a vector it's traveling at. In every millisecond, that vector is slightly changing, as we move through the whole universe. As we spin on the Earth, and then the Earth spins around the sun, and then the sun and the Earth spin around the galaxy, and all that kind of crap. As all those motions take place, they add and subtract and all that kind of crap, and in the end, you're going, whatever, 7,000 miles an hour that way. And then the next millisecond, you're going 8,000 miles an hour that way, because Alpha Centauri is over there, and you're getting a tiny little tug up that way. And then you're going, you're always moving. And you're just saying, when two things interact, they're going to exchange their movement with each other. They're gonna balance it out. They're going to do the math. And so much of this is going to go into that, so much of that's going to go into this, and and a lot of it will be based on this velocity argument, because if it hits it the wrong way, with a bullet, then it just plows through it, and it doesn't cause it to do the moving thing, because it just broke atoms. It didn't push atoms, it broke atoms. It broke molecules, probably a more accurate thing to say. And breaking molecules is different than transferring your energy. It's a different way of transferring your energy. You're just making heat. You're not making pushing pressure. Some way to say it. You're just doing something different. You're doing the difference between on one side of the magnifying glass and at the focus. Those are two different places in space and two different conditions. And so depending on how you interact with something, whether you're interacting with the focus or whether you're interacting, with the force in a more benign state, spread out, will depend on whether you move or whether you just get a hole burned in you. Same energy, though. So what was I was getting to the relativity argument doesn't really mean anything. It doesn't matter whether you think of it as empty buckets getting filled or full buckets getting emptied. Everything does have a disposition. You're just exchanging the ones that are incompatible, the ones that aren't going in the same way. So whatever force you have that's not going the same way, that's what you're going to share. Because the stuff going the same way, you can't fill what you already have. You can only fill spots you don't have. So directions you don't have are the ones you can get. You can't get the direction you already have in the same volume. Obviously, if somebody is going faster, they can push you faster in the same direction, but that's different than replacing what you have with a new direction. Yeah. So the relativity thing doesn't mean there's no absolute space. It doesn't mean that things don't have absolute places in the universe and are doing absolutely things. Like I said, every time somebody's shot with a bullet, you could theoretically argue that maybe the person is moving and the bullet's actually standing still. Like you shot the gun exactly in the opposite direction that you were moving, and now the bullet's standing still, and the person was actually moving on the surface of the earth and he flew into the bullet. You can make up stories like that, but the fact is that there's, you can deconstruct these circumstances and find out pretty quickly that that's not really what's happening. That it's unlikely that you found the right direction to point the gun to shoot the bullet. But we get the same result no matter which way we point the gun. You end up with the same result. You don't have any different in effect. So there's very little evidence that it's not always the case that the bullet's actually flying through. It actually has the momentum. But you can't say for absolute sure. Because there's no difference. There's no I hit you or you hit me. There's just the fact that the two things hit each other. They interact. And so it doesn't matter who hit who. It just matters that they connect, and now they're going to exchange their vectors. Whatever differences they have. whatever buckets aren't full kind of thing. Anyway, that's probably enough of an overview, just a statement to explain. And just to get to the little critical point is that it's just like with the Bohr model of the atom. I mean, there's lots of simple arguments to be made about this idea of the electron having momentum is kind of doesn't work. Electrons are dragged to a halt. Electrons don't travel well. We can't make a literal electron gun. Can't make a gun and shoot electrons across the room and hit somebody with them. It doesn't work. It doesn't work for a reason. I mean, there's no reason why the light gun should work and the electron gun not work, theoretically. The electrons aren't going to hit more stuff and all these other... No. That's just mush. They're going to be just as likely to hit atoms and just as likely and all that other crap. So you really should be able to do it. And the fact is you can't do it is because the electrons are a piece of matter and they are dragged to a halt. And it's only more complex matter. I mean, this is stuff they knew also 100 years ago more. That you have to have a nucleus to keep pushing it, to have it go perpetually in space. You can't throw an electron into space and get it to go from here to Mars. It won't do it. But a helium nucleus will. And so that's a huge difference in understanding, and it gives you reason to doubt, that electrons have perpetual motion, and that they could be orbiting or doing some silly thing like that, and that would make very good connections. So I've pointed out how if you just make a magnetic model for the atom, then you can just put the little north elements and the south element in the center, and you can just arrange them where the north elements repel each other and they are attracted to the south, and it all ends up being in balance. And it works. And now when you connect two atoms by sharing electron, they're literally sharing it. There's no electron moving in all kinds of figure eights and all that crap. But this is a conversation they won't even have. They won't give a tiny centimeter of distance in terms of having any of these assumptions and axioms and premises, these dogmatic statements of truth, examined and questioned. And that's not intelligent. And you can just point your finger and say, "Sheesh, you suck at being smart animals. You did a really bad job of it." And again, it's going to be on your tombstones, so to speak. Okay, you're not going to be the greatest generation. You're going to be a bunch of assholes, a bunch of arrogant, obnoxious, tyrannical, dogmatic assholes. That's what you're going to be known for, is being clock stoppers, progress killers, religious kooks, essentially. You took your intelligence and you just built a new silly totem pole out of it. And that's on you, fuckers. Yeah. Live with that on your tombstone. Yeah. That's the truth of it. And so just keep running, keep playing your silly games that and everybody else is an asshole and an idiot. Keep just being a pretentious douche and prove the point. Make sure it's really clear to the future just what an asshole you were. Unreasonable, pompous douche. AB Science. Puro. Pathetic. Anyway, he'll be the poster child for this kind of retard. The inverted intelligence, he didn't stick his head up his ass. He actually dragged his ass to his head. Ugh, fucking... Not much to say. So till the next time when I attempt again to reason, just reasonable statements about, and evidence is kind of important, and not being presumptuous is that's important. All these little baby talk ideas about how to do science and understanding, you know, seems like isn't necessarily is like. Alright, so this has been a draft physics video presentation. Until the next time in touch.